Hi, this is Sean from Fire Security. We're going to be talking today about passive fire protection and fire stopping in general. Fire stopping being stopping the fire from moving from one room to another. And today we have Reto, our Latin American sales manager, with us. So how are you?
Guys. I'm doing great. How are you doing?
Good. You ready to listen and question me?
I'm born ready.
Oh dear. Okay, that's scary. Okay.
It is.
So what I thought we would do today is also run through a little bit of the life of a fire, which ties in very well to the fire stopping at any rate. So there are basically four stages to the life of a fire: ignition, fire growth, fully developed fire, and then the decay. The picture you see here is the actual decay in itself, what's left after a fire. And especially with electrical cable fires, what you will find is the hydrochloric acid damage on the concrete, also on the trays, and a lot of the machinery around the plant where under fire and underwater, where there's a lot of sprinkler systems, the water hits the cable, creates hydrochloric gas, and then pools and creates hydrochloric acid, which is fully airborne and attacks any machinery. So having a cable fire in itself is not just the fire and the damage the fire creates, it's also a vast array of other things that fire creates. So when you look at a fire, combustion requires heat, fuel, and oxygen, and fire growth is a function of the fuel itself. The fuel in our case, in protection of electrical cables, the fuel is the electrical cable. And it has little or no influence in the compartment configuration. Given sufficient fuel and oxygen, the fire will continue to grow, causing an increase in the compartment temperature. When substantial heat is generated, which is 500 to 600 degrees, full flashover occurs and it becomes fully developed, which is extremely hard to extinguish. And it takes over the whole compartment or the room. And decay follows when there's simply no fuel or oxygen left in the compartment, and everything is burned. So what is passive, or what is fire protection? There's two forms of fire protection. One is passive, which is coatings, mortars, pillows, panels, and active systems, which are sprinklers, suppression systems, extinguishers, gas suppression systems. And the differences between active and passive fire protection. Passive fire protection measures are intended to contain a fire to the compartment of origin. The old school version was compartmentalization. So you compartmentalize room to room, so you're effectively creating blocks, thus stopping the spread of flame and fire, corrosive gases, for a limited period of time. That period of time can be 1 hour, 2 hour, 3 hour, or 4 hour fire ratings. There's no activation method required on a passive system. It activates itself under a certain amount of heat. So active fire protection, let's skip the back, sorry. Active fire protection means that items or systems are activated mechanically or electrically and require a certain amount of motion or activity in order to function. So sorry about that, we had some technical difficulties, as you do. So we'll pick up where we left off, where we left off was the active fire protection, which means that items or systems are activated mechanically or electronically and require a certain amount of motion or activity in order to function. The downside of active fire protection is if all of those functions just like our technical difficulties, are put aside in a storm, or the generators don't back up, or situations like that means that they no longer work. Therefore, there is no fire protection.
Mm-hmm.
So why do we use passive fire protection? We use passive fire protection to protect people and assets, to prevent flame spread to other areas, to prevent the spread of corrosive toxic gases and acids, and to adhere to national and company standards or the requirements of insurers. And we do that with cable coating, of course, which we've already discussed. We do that with steel coating for steel protection, which we've already discussed. And what we're discussing today is our fire stopping. So what we'll do is we have a few systems within our fire security fire stopping systems, and or products within our systems. And we'll start with our FS21 fire stop panel. Now this is a high density rock wool, 160 kilogram per cubic meter density in panel, and we coat the outside of that panel, or it's pre-coated when it gets to the end user, with FS15, so it can be used internally or externally. And it is a 4-hour fire-rated penetration seal for electrical and mechanical surfaces, so steel piping as well as electrical cabling. Not PVC piping, because you would need, on top of a PVC pipe running through your panel, you would need a collar, and we can talk about collars a bit further on. So our fire stop panels, the FS21s, they're a fire-rated penetration seal. It consists, as we discussed, of high-density rock wool and FS15. It has fire ratings up to 4 hours. Consists of single-coated panel, not double-coated panel. Has applications for cables, pipes, and ductwork. Water and weather resistant, because we have the FS15 ablative coating on the outside. It can do extremely large penetration sizes, where the panels are butted together, and we use our sealant FS23A as the glue between the panels and on the edges of the panels when they're friction fitted into the penetrations. Because although the panel is an extremely high density, we can cut through that panel with basically any type of knife. So that means easily retrofitting cables after the panels are installed, not replacing the whole penetration seal. So maintenance becomes an issue with this. And of course, you can reduce your insurance premium due to the protection of your assets. And what that means is, in some instances, insurance companies, because the facilities are taking the step of fire protecting their assets and stopping that spread of flame, that they may get a reduction in premiums. So we have a few approvals for our panel seals. One is it's IFC approved. IFC is an international regulation body who approves fire stopping and other fire protection products. We're also approved for to British standards 476 for 4 hours, and for Part 20 and Part 22. So you'll see in this illustration here, you have a single panel. It's friction fitted installed. So then you will see that the either your copper pipe, steel pipe, or cable tray, or just single cables can run through there. Traditionally, with panels with coating on them, you'd see in this instance that the panel is fitted in here, and then the cables are coated down 300 to 500 millimeters. We retested our system, and now we no longer have to add that cable coating to our panel for 4 hours. You only need the panel and the sealant as the glue. So it's a two-part system, panel and sealant. We also now offer uncoated panel, not pre-coated panel, as an option.
Sean, if you cut too much and you cannot friction fit, you're basically adding a sealant to it around it?
No, the sealant's actually used as the glue on the between the edge of the panel and the substrate, or panel to panel, when you butt them together. If you cut too short, then I would advise cutting a section off another panel and friction fitting that in between. It's a tight fit, and the sealant, and then you would glue that section in too.
With the sealant.
With the sealant, that's right. Now, when the panels get too large, or our panel size is 1200 by 600, so if you've got a 14 or 1800 millimeter size penetration, you need to butt two panels together. Or if it's larger, you can actually use angle or T-junction fittings in between the panels as well to offer a little structural integrity, or angles across that penetration, and then you coat those pieces of steel as well, and that just gives you extra stability. It works out quite well, and you can end up doing quite large penetration seals.
Okay, thank you.
So for the application of the FS21 Firestop panel, it's friction fit only required. It doesn't need bolts, it doesn't need anything else, it's just friction fitted. Slots into openings around the cable trays, and what you will find is when that gets put around cable trays, not just in empty openings, the cable trays actually act as reinforcement within itself as well. So that also holds things together. We use the FS23A sealant. We apply that at joins, but we also apply that at once you've cut the section open for the panel, for the cable tray. You then fit the panel in, and you also use that sealant to seal up the openings around the cable to the panel.
And the cables are folded as well through the penetration?
They don't need to be anymore.
Okay.
The main reason, traditionally fire stopping was used to stop the fire moving from one room to another, and the wall in between would be a fire rated wall. For instance, the wall was a 2-hour fire rating, so when they cut a hole in that wall, then there's an opening in that rating. Therefore, any cable or pipe or utility passing through then had to be filled with a fire-rated material that could cope with that fire. So that's why they're fire-rated penetration seals. Now, if you're willing to lose everything in that room except not move to the next room, then fire stopping is your ideal goal. But if you don't want to lose any equipment within that room, which means your electrical cabling and whatnot, then you would cable coat as well. If you had a fire in a cabinet in a substation, for instance, or a switch room or a cable gallery, if your cables were coated all the way to the gland plate of that cabinet, you would lose the cabinet, but you would lose no cable, because the cable coating, the FS15 or FS11, for instance, would simply stop the fire at its source.
Yep.
And the only reason then the function of a fire stopping system at the wall is to stop the egress of smoke. So everything is contained within that room. So those fire seals then become in actual fact gas and smoke seals, because you've cable coated everything, and there's a zero loss. So that's why we always recommend cable coating over everything else as a first instance, because for the low and effective cost that the customer is getting, everything is protected. So the panel sizes are 1200 millimeters by 600 by 50 millimeters, pre-coated or uncoated, and we angle fix at slab bases for larger penetrations, as we discussed. So our next item is our Firestop compound, which is our FS20. 6-hour fire-rated penetration seal, again for electrical and mechanical services, but it is a mortar. The colour of our mortar is an off-white, which we can colour to any colour that's requirement. Within limits, it's similar to what we discussed with colour coding our coating. You can colour code it, but you have to be careful of the quantity of tint that you put in, because then you reduce the fire retardant material.
Mm-hmm.
And you see here, this is in a cable basement with switchgear above, bottom fed cables. The customer wanted a red, a sort of a red colour in their mortar, so we just added a tint to that mortar. As we said, it's a fire-rated penetration seal. It's a dry mortar mix with controlled swelling to provide a non-shrink, homogeneous and smoke and gas tight fire seal. It has fire ratings up to 6 hours, 75 millimeters for 2 hours, 100 millimeters for 4 to 6 hours. It has applications for cables, pipes and ducts. It can be utilized also as a structural mortar, so you can put reinforcement in the middle, and it is a structural fire rated mortar. So it can be walked on. Easily applied by trowel, pump or by hand, covering large penetration sizes. The larger the sizes, then we would, small sizes of around 500 by 500 millimeter openings, there's no requirement for permanent formwork. When you start to get larger penetration size, permanent formwork is required, and or you're using it as a structural mortar with reinforcement in it.
Mm-hmm.
It's a low density, which means that you can drill through it, and so it is easy for retrofitting cables, quite easy. And you'll see here in the in this cable gurry again that the mortar is red and it runs all the way through. And after that factor, we then came and sprayed all of those electrical cables to stop any spread of flame on all of those high voltage cables. So for the FS20, there's no permanent formwork required for smaller penetrations. No sealant required after cure. The penetration seal, the FS20, expands on cure. It doesn't contract like a normal mortar. Mm-hmm. So a lot of the mortars within the market, they definitely do their job. They stop their fire, but when you install it, they contract, and then you have to come and put a fire-rated sealant around all of the cables. We have packaging of 22 kilogram bags, and as I said before, we have 2-hour fire ratings at 75 mil thickness, which is 3.15 bags per square meter in spread rate. And 3 to 6, or that should be 2 to 6 hours, you're looking at 100 mil thickness, which is 4.2 bags per square meter. And as I said, no sealant required. And as before with the panels, you can reduce your insurance premiums due to lower risk. It is a possibility if it's discussed, obviously, between the facility and the insurance company, because you're lowering the risk of the insurance company as well.
Okay.
So the same as our panel, we have the IFC approval, BS476, Australian Standards 1530 Part 4 for 2 and 3 to 6 hours. And we also carry acoustic ratings for our mortar. So at 50 mil thick, you can reduce 39 decibels up to 150 mil thick, up to 51 decibels in reduction of sound.
That's considerable.
Very, very. So you'll see here, once again, it was that same, they're such good photos, I had to put them in. At a very large penetration seal with cables coming to the penetration seal, and these cables are actually coated with FS15 because that client did not want it. That client was at a zero loss position. They didn't want to lose any asset whatsoever, so they realised that the possibility of losing a cabinet or a machine, but they didn't want to recable everything, which could be a time issue. So they wanted their downtime to be an absolute minimum.
Mm-hmm.
So now we come to our FS22 Firestop pillows, maintenance-free, incredibly quick to install. 4-hour fire-rated expanding pillows for cable penetrations. So our pillows, they expand, they are expanding pillows for cable penetrations. The pillows consist of tightly woven fireproof bag and fireproof string that binds that bag. Has fire ratings up to 4 hours. It expands up to 45% under fire and has applications for cable, pipes and ducts again. Water and weather resistant, so they can be placed outside. Completely dust free, so they can be placed in computer rooms or in hospitals or areas that require zero dust. No sealant required around the pillows. A lot of the systems that you find in the marketplace, once they're packed, they're part of their approval process and testing was actually fire-rated sealant around all of the pillows once installed. And once that's done, you're no longer looking at a quick maintenance fix, because if you have a new cable to put through, you remove the pillow, there should be no issue, but then you've got to reinstall all of the sealant around that pillow to bring that integrity back to 100%. They're fully flexible, very flexible pillows, perfect for high traffic penetrations. High traffic penetrations are when you're moving cables in and out all the time, and you can move cables in and out, pull cables, replace cables, and then reinstall those pillows straight away to bring back the integrity of that penetration.
So you just need to kind of tightly fit them into the penetration?
Yep, just tightly fit them straight into the penetration, and then under fire they expand up to 45%, so you're looking at nearly a 50% growth within the thickness of those penetration seals with the pillows too. They're not the most cost-effective solution we have in our range compared to the panels and compared to the mortar, but these are probably the most effective penetration seals on the market. Pillows are always highly successful products simply because they're in and out. You can get the job done very, very quickly. You don't need a passive fire protection installer. Maintenance crews on site can do this. To do a square meter penetration would take you no less than, or no more I should say, than 5 to 10 minutes at the most. With one person.
And no form work required.
Nothing. No preparation, no substrate preparation, no form work. All you need is the box of pillows, and that's it.
Yep.
So you see here, you can we place pillows under subfloors in computer rooms. When you're looking at pillows in a wall, that's a simple stack of pillows, and you know, like I said, 10 minutes, maybe 10 minutes for a square meter penetration, which means that completing work with the pillows is extremely effective and very cost effective for the facility. They don't have to have a contractor come in and do pillow work. They can use their maintenance contractors or maintenance staff that they're already paying anyway, so there's no overcost. So the Firestop pillows, they're 4-hour fire rated for multiple cables. We have 4 sizes, 50 mil, 100 mil, 150 and 200 mil in widths. So the width of the pillow changes. Cost effective, quick installation, dust free, no sealant, and once again you can reduce the insurance premiums if you discuss, or the facility discusses that with the insurance company.
Sean, what is the situation if it is a plastic pipe that isn't penetrant? Can you use the pillows, or you need to use a mortar and collar?
Okay, so if you're looking at plastic or PVC, UPVC, a myriad of plastic pipes, if that's penetrating next to cables, for instance, through that penetration seal, and you have panel, mortar, or pillows as your fire stop, then you will add a collar. If it's a wall, you will add a collar either side of that penetration in the penetration seal itself. That will just be a function of the penetration seal.
Right, but you could not use pillows for plastic pipes.
No, you do need a collar. We've got our ratings consist of steel pipe and electrical cable, but not PVC, open PVC pipe.
Understood.
You need a greater amount of energy in intumescence to crush that pipe.
Right. Okay. So you will do a mortar or a panel type of situation, put the collars on both ends, fix them against it.
That's right.
And you should be okay.
And if that was in a floor or ceiling penetration, you would only require a collar on the underside of the floor, on the slab soffit.
Yeah.
And here this just shows you the size of the pillows and also the approximate number per square meter of pillows you would require, and that is excluding cable tray. That's only an open square meter. So when you're adding cable trays to that, you would just take that square meter rate and minus that out of the overall penetration.
Okay.
But mind you, all of these things and all of the functions and all of the quoting methods, spread rates, and we have full charts and Excel spreadsheets and programs that we can email to you or to the end user, and they can walk around on a tablet and calculate it straight away. And they will already know how much that they would require for that site. So really, if they're using our program, our quoting programs, they only need to come back to us with a freight quote to get that to site.
That makes it very easy.
So our FS Firestop pillows not only have a fireproof bag, but also contain ceramic fillers which bond together under fire. At 130 degrees Celsius, they start to glue together. At 280 degrees, they start fully expanding. And at 800 degrees, they have what we call a ceramic effect, which is hardening to a ceramic block. Effectively becomes a wall tile, and nothing will get through that. So because of the structure of the pillow, because we went for our 4-hour test, we didn't fail or just achieve the 4-hour test. We simply turned it off after 4 hours. It may have gone for 8 hours, but the laboratories at Warrington just sort of decided we were coming to the end of the day. Can you please turn off your test? We need to go home.
That's very efficient, really.
Very, very. They're the most efficient product that we have as far as fire stopping is concerned. There's no doubt in my mind that these are probably, if not the best product that we have as far as fire stopping is concerned. Simply, and it's not just for its fire protection properties, it's also because it carries so many other things with it as far as the installation is concerned. Ease of getting product to site, easily packaged, unpacked, get into that penetration without any substrate preparation. So it's very quick and easy. So not unlike our mortar and panel, IFC approved, British Standard approved, British Standard ENORM approval for Europe, and also AS 1530 Part 4 for Australia. So we come to our range of sealants, which we have two. FS23 fire-rated sealant, which is 2-hour fire-rated high expansion sealant for electrical cables and steel pipe penetration. Perfect for small core holes. They come in 310mm tubes. So we'll just get through this slide. So it's a high expansion, durable and flexible one-component water-based fire-rated intrumescent sealant, grey in colour. Has fire ratings up to 2 hours, expands to 800% under fire being an intrumescent. Has applications for cable, steel, copper, and some very small plastic pipe, extremely small plastic pipe. Water and weather resistant and packaged in 310mm cartridges, and as we said, it's a dark grey. These are extremely effective solutions, sealants and tubes, for small penetrations and core holes running through, and myriads of commercial buildings have hundreds and hundreds, maybe thousands of penetrations, little tiny penetration seals that they have to fill up. And it's perfect for maintenance. It's not a rocket science application here. It's simply putting that nozzle into the edge of the penetration and squeezing until it's full, and you walk away.
Is there a specific depth that you have to kind of consider filling?
There is. We look at, get this thing to work. It's not going to work on me. We traditionally, I think we've got it up here, see, installed at 40 to 75 mil thickness. And there's no backing. Traditionally, sealants have a backing rod placed into it, whether it's a polyurethane backing rod or a mineral wool. You would place the mineral wool, for instance, down 40 millimeters and then fill up the top of the penetration to the top of the slab. But we don't need to do that. Most of the time what you find is that people will always install pretty much to the slab thickness because you want to get out of there quick and easy. But you know, install 40 to 40 millimeters minimum, up to 75 mil thickness. So that's its range of installation. The only thing that you do need to do is to clean and wet that substrate before putting the sealant in there, which gives you a bond or an adhesion.
Right. You know, to avoid all the break.
Yep, that's right. So again, with our approvals, with our FS23, Australian standards, British E-norm standards, BS476, and third-party IFC approval as well. With our FS23A, it's a 4-hour fire-rated intumescent sealant for joints and electrical cable and pipe penetration seals. When we look at the electrical cable and pipe penetrations, that is in conjunction with our panel seal as part of its system, but 4-hour fire-rated for joint work. And where our previous FS23 had no backing rods, this does have backing rods, especially for joint work. So it's an intumescent sealant, durable and flexible, one-component water-based fire-rated sealant. Fire rating's up to 4 hours. As it's an intumescent, expands up to 800% under fire. Cable, steel, copper, plastic pipes, and joints. Water and weather resistant, 310 mil cartridges, standard applicators, and it's installed in 10 to 20 mil depths in joint work, concrete joint work, with PE backing foam. So you would poke that back.
Polyurethane?
Polyethylene.
Polyethylene.
I think I called it polyurethane before, but it's polyethylene, sorry. And you can, you know, that's available at local hardware stores on rolls. And all you would be doing is poking that polyethylene foam down through the joint itself, 10 to 20 millimeters in depth, and then running a bead of sealant FS23A along that joint, and then smoothing it over with your finger to create a nice effect. But,
right.
Very. Sorry?
You say plastic pipes again, very small diameters.
Very small diameters, yeah.
What is it? Small diameter, less than an inch, or?
Yeah, well, an inch and under.
Inch and under.
Inch and under. But this is a, you know, the FS23A is a very effective solution because it kills two birds with one stone as far as the cables and the joint work is concerned. And that's very cost effective. FS23 is not an expensive sealant at all. So with its approvals, very similar to our complete range. Obviously, as you will see, they're all very similar because we took our whole system to get package approved. IFC, BS476, British Standard E-norm, and AS1530 Part 4. Our Firestop system does not carry any FM or UL approvals with it. We stopped at that point because simply the expense of continued testing or different testing at different laboratories becomes rather harsh, where we can go back to Warrington and continue our British Standard testing, and because we're already entrenched with that facility, that's where we stay, and it's a lot more cost-effective solution for us.
So if the customer would be looking for an FM or UL kind of approval, will we do an engineering letter to it, or?
Well, we can. Well, no, we won't. We can only recommend that what we have. If they're looking for an FM approved system, I'd ask why. because there's no difference. And this actually comes back again to what we talked about with our steel coating. Usually an FM approved product is FM approved by FM Global because they're an insurance company and they test their own products. They don't accept any other testing facilities products. So they don't, even if you've got a UL approved product and it's not FM, FM won't let you use it. So it can get pretty tricky sometimes. It does come to obviously the customer's choice of what they would want to use. So our FS24, which is our last product within our Firestop range, which is a 4-hour fire-rated pipe collar. And these are what we were talking about earlier when you're looking at a pipe as well running through that penetration. We would use this or this type of product. Now, for instance, if this was just an open penetration within the wall, and this was mortar, you would the pipe would run through. You would seal the pipe up with the mortar, of course, but then you would put a collar on either end. Because these diameters can get large, we can protect up to 200 mil diameter pipes, but the mortar will not crush that pipe, the collar will.
Yep.
So FS24 Firestop collars are suitable for plastic pipes 30 mil to 200 mil diameter. We have fire ratings up to 4 hours and suitable for sealing a multitude of plastic from PVC to PE plastic pipes, HDPE. Large annular gaps fill with FS23 HE sealant, which is our high expansion. And what we mean here is that what we have in this instance is if this was a 50 mil diameter pipe and the core hole here was 60 or 70 mil diameter, so it had an annular space in between, we would fill that full of sealant because the annular space is too large for the pipe, so it needs some extra filling there, and that just adds an extra ounce of fire protection to it. We can actually, under the tests we did, it's either FS23 or FS23A sealant that we can use in there. Very simple to install, just bolt in straight away, fire rated bolts that come with the unit. The collar is placed flush to the wall on or the underside of the floor, securely fastened with the fire resistance screws provided. And one collar required for the underside of floor and one collar either side of wall. And once again, our approvals, Australian, British Standard, British E-norm, and IFC. So there's a vast array of products there for penetration seals, but we keep. I think we discussed this the other day. That there's other companies that sell 400 different types of penetration seals, but traditionally facilities really use either mortar panels, sealants, or collars. And for high volume penetrations, they always run towards the pillows. We could carry and we could develop and we could spend a lot of money in R&D and do blocks and all of these sort of things, but traditionally industrial facilities as well as commercial and semi-industrial always lead towards that mortar and panel scenario because of size penetrations too. A lot of the products on the market today can only do small penetrations, where larger industrial facilities can have 2 and 3 meter penetration seals. So they have to be filled with and reinforced properly. So that's why we have our panels which you can add to, and also you have your fire-rated mortars, the FS20s, which are also reinforced and then become a structural mortar. So and still at low density. So
if you say reinforced, does that mean also that you put like a mesh in half of the thickness of the mortar, that you
yeah,
kind
you
of
would,
half of it, and then you put the mesh on it?
Yeah, traditionally, I mean, if you're laying concrete, for instance, you're going to have a lower run of reinforcement or mesh, depending on the density of the concrete and what it's used for and the integrity of the concrete, and then an upper level of mesh, usually with a surface depth of around 25 to 50 millimeters. But with this mortar, we're only talking about putting some reinforcing rods in the center of the mortar to reinforce it, to make sure that if someone does step on that, they're not going to step through it.
Yeah.
It doesn't need to be an engineered situation unless it's a very, very, very big penetration. And then you'll be wanting to talk to us and also the structural engineers on site, not the electrical engineers, to engineer the system for the mortar and also to carry that load. So we have to be careful and on the sizing, and that's why we always want to ask, and and it comes back to the last two discussions that we've had on our other products. It's lovely when someone comes and says we just want to buy 100 bags of mortar, but where are you putting it? How are you putting it in? Because that's and how many square meters are you looking at? They might be calculating out, for instance, KBS mortar. That 2-hour fire rating is 200 millimeters thick. Our 2-hour fire rating is 75 millimeters thick. And the vast differences of the research and development we put into our product to get it to that 75 millimeters thick. But they might be calculating their quantities based on that 200 millimeter thick spread rate, which is 5.6 25 kilogram bags, where we only need 3.15 22 kilogram bags per square meter. So for the customer, it's always good to ask how many square meters or how many openings or what the opening sizes are, and let us calculate it out for us. That's what we're here for. And at least then they're not buying overkill or buying under what they require either.
Yeah.
So it's very important, and it gives us an understanding of their requirements and their needs, and in discussions with them, they also get an understanding and a clear definition of what the product is capable of. So it's very important that we do have that clear discussion with the end user to understand their requirements.
Yeah, understood. Yeah.
Okay, well that's our fire stopping range. Do you have any other questions, Redo?
Not really. I mean, I do know that if penetrations are too large, that you can use panels basically to kind of shut them down and then friction fit the surfaces through it in order to comply with a specific type of approval.
Yeah.
And I guess that's what we would do with our products as well.
Yeah, definitely. And like I said, we're a phone call and a plane away to get to that site and to make sure things are being done the right way for the end user.
Yeah.
Okay, well, thank you very much again for listening and joining me in going through the products.
Well, thank you, Sean.
No problem.
Thank you.
Okay, well, all the best. I will speak to you soon.
Okay.
Bye.
Thank you.